All right, welcome to the first task of Algebra 2. We're going to deal with some absolute value equations. Remember, absolute value is the thing where if I were to put a negative number inside those absolute value symbol, out comes a positive every single time. Same thing if I were to put a positive number inside the absolute value, I would still get a positive number. Always equals a positive. And so the first question we want to think about is if the absolute value of x is 7, what are the possible values of x? What could I put into absolute value symbols in order to get a positive 7? Well, I could put negative 7 in there and I'll get positive 7. Or I can put a positive 7 in that absolute value symbol and get a positive 7. Both are correct answers, and so both would be solutions for that equation absolute value of x equals 7. The second question there is saying if absolute value of x equals negative 4, what are the possible solutions of x? Well, if I put a positive 4 in, that would equal positive 4, right? Same thing up here. If I put a negative 4 in, that would also equal a positive 4. There's no such situation where I get negative 4 as an answer. So here we have no solution. And this works for every single time the absolute value equals a negative number. No solution will actually just be your answer. So solving an absolute value equation, most of the situation is very similar to solving a regular equation. The only difference is this step right here, which is really important. We are going to create two cases. We're going to set the inside of this absolute value symbol equal to both the positive and negative value of the number on the opposite side of the equal sign. So when I have x minus 9 equal to 5, what I'm actually going to solve for is the equation x minus 9 equals 5, or I'm also going to get this equation x minus 9 equals negative 5. Both are going to give us one solution. I'm going to end up getting two solutions for my absolute value symbols. So x minus 9 equals 5. I'm going to add 9 to each side. That way I get rid of that minus 9. And I'm left with x equals 14. But I'm also going to do the same thing over here. I'm going to add 9 to both sides. And I'll get x equals a positive 4. And those are my two solutions. You need both in order for your answer to be correct. Let's try number 4. 3 equals the absolute value of 2k minus 7. Here's my absolute value. I want it to equal both the positive and negative of this. So I'm going to have 3 equals 2k plus 7. But I'm also going to have negative 3 equals 2k plus 7. And those are the two equations I'm going to work out. I'll start by subtracting 7 to both sides and getting negative 4 equals 2k. Then I'll divide by 2 and I get negative 2 equals k. Then I'm going to do the same thing with the other side. I'm going to do the same steps, just I'll get a different answer because I'm starting with negative 3. So this time when I subtract 7, I get negative 10 equals 2k. And when I divide by 2, I get negative 5 equals k. All right. These last few examples we're going to show is where we're going to have to pay attention to this first step right here. Isolate the absolute value expression. I want it to have something inside my absolute value equaling to one number outside. So when I have number 5 here, the absolute value of y minus 1 plus 17, I want to get rid of that plus 17. I'm going to start by subtracting 17. And I'm left with that y minus 1, the absolute value of y minus 1 equals 6. Now this is isolated. I can break it up into two separate cases. Y minus 1 equals 6, and y minus 1 equals negative 6. And that'll give me my two solutions, right? I'll add 1 to both sides. I'll get y equals 7. And adding 1 to both sides, I get y equals negative 5. Those are my two solutions. So isolate the absolute value and then separate into two cases. With number 6, I have a 3 hanging outside of my absolute value symbol. That is being multiplied. So the inverse would be to divide both sides by 3 in order to isolate that absolute value symbol. 39 divided by 3 is 13. And now I can separate into my two separate cases. M plus 8 equals 13, and m plus 8 equals negative 13. Those are my two separate cases where now I can subtract 8 to both sides, and I get m equals 5, and m equals negative 21. Last two examples. Number 7 is going to be the exact same situation. I'm going to divide by 16 starting off the back. And so I get the absolute value of r minus 5 equals negative 32 divided by 16 is negative 2. Right here, where I have an absolute value equal to a negative number, this should set off a big red flag because there's no solution when absolute value equals a negative number. Anytime we isolate the absolute value and we get a negative number equal to my absolute value, my answer is no solution because this is a negative. All right, last one. Now looking at this one, it looks like it's equal to a negative number. However, my absolute value isn't isolated yet. Right now it's being divided by negative 2, so I'm going to multiply times negative 2 on both sides. That way my negative 2's cancel out. I'm multiplying by negative 2. I get y minus 10 isolated. Negative 6 times negative 2 is a positive 12, so that does work out. And I can separate into my two separate equations. Y minus 10 equals 12. And y minus 10 equals negative 12. So I can add 10 to both sides. And I get y equals 22. Or this last one, I get y equals negative 2 as my two solutions. So as long as that absolute value equals a positive number, we can separate it into two equations and find two solutions. So then take your time, flip over to the back side, and complete this entire back side on your own. Check your answers with me at the end.